Hello friends, so this is the introductory lecture about the course defects in crystalline materials. Now why do we need this course? So as you all will be knowing that crystalline materials show many properties and phenomena which are dependent on defects, the presence of defects. For example, metal whiskers, they have very high properties, and then nanofibers, they also have very high properties, they are very high strength. Why is it? It is primarily because of the absence of defects in these materials. On the other hand, you can also have very deformed materials where the defects are present in very large quantities, and then again they show very large mechanical strength, mechanical behavior properties. So what we see is that the existence of these defects determine a lot of these properties, particularly mechanical properties, and hence to understand properly how these defects can influence the properties, we need to understand the defects in these crystalline materials. There are also some phenomena where the interaction of these defects can lead to some interesting phenomena. For example, you must have heard about the yield point phenomena, where what is actually happening is that dislocation lines interact with point defects, and this interaction leads to the phenomena called as yield point phenomena, again which leads to improved strength. So again you can see that the presence and existence of these defects, their interaction can lead to interesting properties, and therefore this course intends to explore these defects and its effect on properties, primarily mechanical properties. Now defects can be classified as 0 dimensions like point defects, 1 dimension like dislocation lines, 2D defects, for example you can have circle of defects present in one line or a grain boundary plane, 3D defects, for example precipitates. Now all of these are different kinds of defects, and the one that mostly influences the mechanical properties is the dislocations, which is the 1D defects. Hence this course will primarily deal with introducing and explaining this particular dislocation defects and its interaction with other kind of defects, for example the point defects, its interactions with grain boundary defects, its interaction with 3D precipitates. We will understand in this course fundamentals of the defects like structure, energy, their interaction forces, and how much is the force per unit length that is applied when they start to get closer to each other, and how it can manifest in different properties, and then understand these defects in more detail in different crystal systems, for example simple cubic system, body centered cubic system, face centered cubic system, and other compound systems where which is more complicated than these simple cubic systems. Now this will be a very large course, so we have split it into two parts. The first part is a 20-part lecture which will primarily deal with introducing to 0D defects, 1D defects and 2D defects, and then understanding their basic structure and energy forces, and then we will start with the BCC, the defects in detail in BCC. So who will this course be useful for? This will be a good course for all UGs in particularly in mechanical engineering, metallurgical engineering, aerospace engineering and industrial engineering. It will also be a good course for first year PG students, and this course would also be useful for people who are working in industries to build up fundamentals related to mechanical properties and defects in materials. So for people working in automobile industry, manufacturing companies, iron and steel companies and OEM manufacturers. So I hope you like this course. So please do participate in this course in large numbers and make full use of this platform called MOOC. Thank you.